So we'll start by recalling the concept on pharmacodynamics. In the previous recorded lecture video, no, this was highlighted, emphasized, which is one of the primary branches in pharmacology. In operational term, this is also defined as what the drugs do to the body. So that's the focus in this branch of pharmacology. So what does the drug do to the body? Yung mga drugs, when it is administered in the body, of course, they target macromolecular targets no sa katawan. So they need to target, example, proteins, nucleic acids in order for them to produce certain effect. Okay, so yan yung uh, actions or yung role ng gamot when they are being administered to the body. However, you have to realize as well that not only drugs could interact with the macromolecular targets in the body, but we also have natural substances, or we call them endogenous na mga compounds, which are also capable no, to interact with the receptors, with the proteins or nucleic acids in the body. Okay, let's say for example, so isulat ko ha, aside from those drugs which are of exogenous sources, other substances which are being synthesized naturally sa katawan may also interact in the proteins or nucleic acids sa katawan. So we call them natural substances or the compounds. Endogenous compounds or natural chemicals. Okay? So specific examples of endogenous compounds, yung naturally produced ng katawan, as in de novo synthesized in our body, we have neurotransmitters, for instance. Okay, so yung neurotransmitters, it will be more explored sa pharmacology on ANS, autonomic nervous system, and central nervous system. So we'll just learn more about neurotransmitters when we proceed no sa mga topics related to nervous system drugs. Okay, so I'll just still provide specific example ng neurotransmitters for you to have an idea. So example, norepinephrine, acetylcholine. Yan, these are examples of neurotransmitters. Glutamate, also GABA or gamma amino butyric acid. It's an amino acid. Okay, and even glycine. Okay, so these are examples of neurotransmitters. Importante na mga natural chemicals for the transmission of signals no, sa nervous system. Okay, so involved sila sa physiology ng nervous system. Okay, so they will also be mentioned later sa mga preceding slides. Other endogenous compounds may include hormones and also otacoids. Okay, for now, just know this mnemonics, although we'll have a separate segment or a separate discussion or in detailed natin, madadiscuss yung all about otacoids. But for now, know this mnemonics for you to easily recall what are examples of otacoids. So we have bradykinin, yung BASH, bradykinin. We also have eicosanoids, serotonin as well, serotonin. And yung last, histamine. Okay? Ang mga otacoids, they are also known as local hormones. Okay, kindly take note of that. Magkaiba po yung local hormones at saka yung real hormones, yung true hormones. Okay, let's try to distinguish the difference between otacoids versus hormones. Okay, again, otacoids are also known as local hormones. So what's the difference between local hormones and a true hormone. So first is the site of release and its effect. For otacoids or local hormones, the site of release is also where the site of action is. Kung saan siya na-release, doon lang din yung site of action niya. Doon lang siya mag-e-effect. Okay, site of release is where the site of action or near the site of action. Okay? And based sa term local, so it will just produce a local effect. Okay, local. Kung saan nga siya na-release, doon lang din locally yung effect niya or yung site of action niya. So local, it will just produce a local effect and it is produced by many cells. Okay, it is being produced, okay, virtually by many cells. Many cells. Whereas for hormones, systemic yung effect niya. Once released, you can write it, once released, it will cause systemic effect or it produces systemic effect. Okay, so magkaiba sila with those local hormones. So again, systemic yung effect niya kumpara sa local hormones. And this time, ang hormones, there's only a particular cell that produces certain hormones. So please take note, it is only produced by a specific cell. Okay, produced by specific ayan, cells. Sige, for you to uh, s- uh, kumbaga easily understand the difference, we can give example. Okay, para mas madali siya maintindihan. Example, insulin. Diba, insulin is classified as a hormone or it is also even classified diba, as a protein, but more likely a hormone. Now, maybe some of you already know what particular gland in the body that produces insulin. Diba? It is the pancreatic gland. And wala nang ibang gland, okay, or organ sa katawan or cell sa katawan capable mag-release na or mag-synthesize ng insulin. So insulin is only produced by one particular cell in the pancreatic gland and that's the beta cells in the islets of Langerhans ng pancreas. And once it is released, di ba systemic yung effect niya. It is the one that regulates or controls blood sugar level. So systemic yung effect niya. Whereas for local hormones, let's say for example, histamine. Ang histamine, it is being produced by many cells. Example, parietal cells in our stomach. We also have basophils, mast cells that are also capable releasing histamine. So maraming cells sa katawan that are capable to release or synthesize insulin. And kung saan siya na-release, dun lang din locally yung effect niya. Okay? So that's the difference between local hormones or otacoids versus hormones. Okay, so let's go back to this concept na itong tatlong given are examples of natural substances na pwede din no, mag-interact sa katawan to produce an effect. Now, talking about drugs, when designing drugs particularly or let's say discovering drugs, ang mga medicinal chemist, they usually synthesize drugs that at least resembles structures with that of the endogenous or natural substances. So kumbaga yung modeled nila, yung drugs na gusto nilang i-discover, it should modeled with the one that is naturally produced sa katawan. Okay, so that's actually the ideal way to design particular drug. Okay, so these are exogenous again. Exogenous compounds, foreign nga substances. Okay, yung drugs. Now, technically, meron tayong term na ginagamit if a foreign substance, example nga, yung gamot, kapag na-administer yan, nakapasok yan sa katawan, we term that as xenobiotics. I think this was mentioned in your medicinal organic chem. Di ba you have your book? Na siya sa first chapter. Ang xenobiotics, yan yung term, technical term that we refer to those foreign substances, just like drugs, if it is already administered inside the body. Okay, that's xenobiotics. Okay, so overall, that's the difference between endogenous compounds, so galing inside, versus exogenous substances. But both are capable to interact with the target, with the molecules in our body. Then later on, producing a response. Okay. Now, in learning pharmacodynamics principle, it is also important that we understand how the drugs produces mechanisms of action, why they produce an effect. So there is a specific way how they interact with the body, or there's a specific mechanism, no, or mechanism of action for them to produce a unique response. So that we need to learn in this session. We actually have two general ways or mechanisms for a drug to produce effect. We have those target protein mediated. We also have non-target protein mediated. Okay, now when we talk about target protein mediated, these are examples of drugs that produces an effect by binding or targeting a protein, or they are also known as protein targeting. Okay, they need to bind to the active site of the protein in order to produce a response. So examples of proteins that they target: structural proteins, regulatory proteins. So we will be learning examples of drugs that targets these types of proteins. Okay, so under regulatory proteins, there are four classifications or four types. So once again, we will be mentioning later few examples of drugs that targets each. Okay, for easier understanding. And then after that, we'll proceed with those drugs that that do not anymore bind to a protein or do not interact with a protein, but they are still able to produce an effect. They causes a response to the body. So mga non-protein targeting naman yun. Okay, so yeah, let's start with uh, protein targeting, okay, ng mga gamot. Okay, so again, let me repeat, kapag target protein mediated, and the drug has to bind to the protein. So the drug, okay, has to bind to the active site of the protein. So what are examples of those protein nga pwedeng i-target ng gamot? So we have structural proteins, for instance. Before ang specific example ng structural proteins, let's first understand the type of protein itself. Based sa term structure, importante yung mga proteins na to for the structure or cell framework or the cell shape. Okay, or cytoskeleton. They maintain the cytoskeleton, okay, of a cell. So usually, ang mga structural protein, ito yung nagko-compose sa structural elements ng connective tissues like sa cartilage, sa bones. So technically, importante sila for cell shape. Okay, so cell framework. Specific example ng structural proteins, we have tubulin and also microtubules. So ito yung mga specific example ng mga structural proteins sa katawan. And of course, as a protein, they have different functions, important functions. Okay, so particularly importante yung mga structural proteins for cell movement. Okay, importante for cell movement. We also have those structural proteins important for mitosis, yung cell division sa katawan. Also for axonal movement of neurotransmitters. So these are just few of the most important functions ng mga structural proteins like tubulin, microtubules. Okay? Now there are drugs available in the market that could treat particular conditions or diseases na yung manner nila to produce an effect is via targeting these structural proteins. Let's say, for example would be colchicine. I hope you were able to access the recorded lecture video we had sa other section. This was mentioned, no, ang colchicine. Ang colchicine class, it is an anti-gout, okay? And as mentioned sa previous discussion, its mechanism of action has something to do with targeting tubulin. Diba? It is able to depolymerize or it causes depolymerization of tubulin. Okay, so that's the MOA or mechanism of action for a colchicine to cause anti-gout effect. Okay. So with that action of colchicine, then we could tell it is a protein targeting drug. Diba? Kasi nga, kaya niyang i-target, i-depolymerize, i-inactivate yung tubulin. Okay, so for the rest of its kumbaga detailed na discussion regarding colchicine, you can just access the recorded video we had sa previous slides. Okay? So yung point lang dito nga discussion is identifying a particular drug that is protein targeting. So colchicine is one example based sa kanyang mechanism of action. Okay, let's have another example. Other examples that also target structural proteins are the following. Yung vinca alkaloids like vincristine, okay, or vinblastin. These are examples of alkaloids. And also the drug Taxol. This is a brand of paclitaxel. Itong mga gamot na to are used as anti-cancer. Okay, anti-cancer agents or anti-cancer therapy. Or they are also used as anti-neoplastics. Okay. Now, with regards to their mechanism of action ng vinca alkaloids, Taxol, it has something to do with inhibiting the action of microtubule. Okay, it is an agent classified as anti-microtubule. Okay, so given that idea sa iyahang action or mechanism of action, then we could tell these are also examples ng gamot na protein targeting sila. Kasi they need to target microtubule, isang structural protein. Now, let's try to understand here or explain why these two agents can be used as anti-cancer given the idea that they have anti-microtubule nga activity. Sige, we'll start with the property of cancer cells. Okay, susulat natin. Class, ang cancer cells, just like the normal cell, kailangan nila yung process na mitosis. Yun nga lang, abnormal yung manner nila to cell divide. Kumbaga, mas mabilisan yung manner of proliferation nila. They rapidly proliferate, they rapidly cell divide. Yan yung property, diba, ng cancer cells. They reproduce rapidly. Okay? And that way of cell division, we call it mitosis as well. So just like our normal cell, mitosis din yung process ng cell division. Okay? Pero pang mabilisan nga lang, no? Rapid yung manner. Okay? Now, with regards to mitosis nga stage or process of cell division, there are proteins that are involved in this process. As we mentioned, there are structural proteins, example, microtubules, important for mitosis na process. Okay? So kindly take note of that concept on physiology related to cancer cells, mitosis, and then microtubules. Now let's go back to the mechanism of action ng vinca alkaloids and taxol. Why they can be used as anti-cancer agent. Going back, they can target microtubules. Inhibited yung microtubules, thus pigil yung mitosis process. Kaya mapipigilan yung reproduction ng cancer cells. That's why they can be used as anti-cancer agent. Okay? So that's the relationship niya sa MOA and yung therapeutic use niya being an anti-cancer agent. So overall, these given examples ng gamot we have written are all protein targeting. And what particular protein they target? Structural proteins. For colchicine, it targets tubulin. For vinca alkaloids, taxol, they target microtubule. Then just add here, although it's an antifungal, but somehow it targets structural protein based sa kanyang mechanism of action. Yung antifungal nga griseofulvin, it's an antifungal. And yung mechanism of action niya is it inhibits fungal mitosis. Okay? Ayan. Kasi pag mitosis na process, again, there are structural proteins, diba, involved. So given this information nga yung MOA niya has something to do na inhibiting fungal mitosis, then most probably it's a protein, structural protein targeting na gamot as well. Okay? Now, can you show a thumbs up if you follow the topic, if you understand the concept presented on the slide? Okay. Sige, let's proceed. So we're done with structural proteins and examples ng drugs that target structural proteins. Sige, let's proceed with another type of protein na pwede target ng mga gamot. So we have regulatory proteins. Okay, sige, let's try to understand first what are regulatory proteins. So base ulit sa term na ginamit, regulatory, so it is used as regulator. So they regulate, yung function nila is regulating cells activity or the cell's function. They are to regulate cells activity or cells function. So we actually have 4 types of regulatory proteins. So we have the voltage gated ion channels, carrier molecules, enzymes, and receptors. So we will be discussing each and ano yung mga example na gamot that targets each regulatory proteins. Okay, sige, let's start with voltage-gated ion channel. Okay. Now, examples of voltage-gated ion channel, we have sodium ion channel. Ayan, sodium ion channel. Also, potassium ion channel. Maybe you have heard about this already. Calcium ion channel. Pag moingon tag ion channel, voltage-gated ion channel, this is an example of a transport system embedded sa cell membrane. Okay? So, base sa term, it's a channel, it's a passage. Okay? Passage siya, daanan, na usually embedded sa cell membrane. And what passes through that passage or channel? Ions. Okay, ano ba yung mga ions? Ions are charged atoms. So, magdedepende kung ano yung pangalan no, ng ion channel, yun din yung ion that will pass through that channel. Okay, so if it is a sodium ion channel, then sodium ion will pass through that channel, so on and so forth. Okay, sige, let's extract one example. Okay, so you have, for example, this is a cell membrane, and embedded on it is a voltage-gated ion channel na sodium ion channel. Let's say resting state pa siya. So kung pag resting state, close pa yung channel. Resting state, it is not stimulated, it is not depolarized. So it's just resting. Ibig sabihin, if we go back to this mnemonics, no, ang sodium ion at resting state, makikita outside of the cell. So ito yung outside, kung ito yung inside. So at resting state, ang mga sodium ion nasa labas. Okay? Piso, naalala yung piso, potassium in, sodium out. So yung mga sodium ion, normally, they are found outside or sa extracellular fluid cation. Now, whenever from a resting state, merong stimuli na na-feel yung cell, causing it to stimulate, or we call it depolarized. Kapag na-depolarized yung cell, making the inside of the cell positive, that will cause opening of the ion channel. Okay? Mag-open yung ion channel, causing influx of the said ion. So, papasok yung sodium ion, okay, from that cell. Okay, so meaning, ang isang voltage-gated ion channel, it will transiently open. Okay? Depende kung merong voltage or stimulus na ma-feel yung cell. Kung saan doon naka-embed ang ion channel. So it will just open after or kumbaga in response to a cell after depolarization. Okay, kapag na-depolarize yung cell, then it will open the ion channel. So it will depend on the voltage. Kaya nga ang pangalan voltage-gated ion channel. Kapag may nakita siyang difference sa concentration gradient ng ions inside and outside of the cell, it's already a voltage, no? Or kumbaga stimulus, mag-open yung channel to just restore or balance, okay, the charges, okay, inside and outside of the cell. Okay, so that's how a voltage-gated ion channel works. Now, with regards to the direction, what would be the direction of the ion? Is it going inside or outside of the cell? You have to know the normal nga location sa mga ions, if it is found intracellularly or extracellularly. That's why very important yung mnemonics, no, na Miko, Piso, Ficlo. Dapat alam nyo saan ba nakikita normally at resting state si sodium ion, si calcium ion, si chloride ion. That's the time you will be able to distinguish kung ano yung magiging direction ng ion. Is it going inside or outside ba? Sige, let's have another example. I-simplify na lang natin yung ion channel. Let's say this is potassium ion channel. Sige. Potassium ha, potassium ion channel. Let's say na depolarized. Okay? Na depolarized yung cell membrane na merong potassium ion channel. So my question now is, what would be the direction of the potassium ion once the ion channel opens? Is it going outside or inside the cell? Yes? You may make use of the chat box. Is it going in or out? Outside of the cell. So you have a potassium ion. Okay. I thought you're not answering. You're not responding. Yes. It's going out, no? Outside of the cell. So potassium ion will go out. Why? Kasi at resting state, balikan niyo yung mnemonics na piso, potassium is inside. So kapag nag-open yung potassium ion siya, nalalabas lang siya. Kasi nasa loob man siya, lalabas lang. Kung sino yung nasa loob, lalabas. Kung sino yung nasa labas, papasok. Okay? So that's the concept ng voltage-gated ion channel. I think na-mention ko din to, no, sa biochem when we discuss about transport system. So you can make use of that concept as well. Sige. Now, with regards to the drugs, okay, so these are just introduction sa voltage-gated ion channel. Let's try to give examples of drugs that targets a voltage-gated ion channel. So we mentioned earlier sodium ion channel. Example of drug that targets a sodium ion channel are sodium ion channel blockers. Okay, so ito na yung example ng drugs. Sulat natin drugs that target sodium ion channel. Kapag may dagdag na sa pangalan na blockers, that's already a drug. Okay, kasi sabi dito, it inhibits, it blocks sodium ion channel. Specific example of a sodium ion channel blockers are the local anesthetics. Okay, so you write it. Local anesthetics, and usually by name, they ends with the suffix "cane". Example, lidocaine, benzocaine. Ang mga local anesthetics, you will also learn this, no, sa medicinal organic chemistry. There are two types. Depende sa ilang chemistry or depende sa ilang structure. Or we call it structure activity relationship or SAR. Meron tayong ester type or amide type na local anesthetic. Okay, so base ni sa ilang structure. Natay mga local anesthetic na may ester sa kanilang structure, meron din na may amide or amide sa kanilang structure. So base sa pangalan, pwede niyong gamitin ito na palatandaan. Kapag ester type, usually sa pangalan, isa lang yung letter I. Okay? Isa lang yung letter I. Example, benzocaine. Isa lang yung letter I. Although it does not apply to all examples ng ester type, local anesthetic, pero karamihan, no, majority sa mga ester type, isa lang talaga yung letter I. Palatandaan lang yan, ha? Then for for amide, we have lidocaine nga example. Amide type nga local anesthetic. Dalawa yung letter I. Palatandaan lang yan. Okay, but again, this does not apply to all local anesthetics. Okay, majority lang, base sa majority. Okay? Sige. So that's a specific example of a group of drugs nga sodium ion channel blockers. With regards to the detailed discussion on its mechanism of action, pathophysiology about uh, what type of condition saan siya ginagamit yung mga anesthesia, we will discuss this sa final term, yung mga CNS drugs, pharmacology on central nervous system. Okay? So, utang ko muna yon. For now, ang inyo halangsang i-identify dito is isa siyang protein targeting na gamot. Kaya ko siya sinulat. Okay, protein targeting. Ito sila kasi they are able to target a voltage-gated ion channel and protein man ito. Okay, di ba isa siyang regulatory protein. Sige, next. Example of drugs that targets or inhibits potassium ion channel are those blockers of potassium ion channel. So example specifically ng mga potassium ion channel blockers are the antiarrhythmics, particularly yung class 3 antiarrhythmics. Class 3 antiarrhythmics, specific example yung amiodarone. Okay, so yan ay example ng antiarrhythmics na yung MOA niya is via inhibiting potassium ion channel. So isa siyang protein targeting din, no? Protein targeting na gamot. Okay, another example na potassium channel blockers are those antidiabetics, mga antidiabetics classified as insulin secretagogues. Okay, secretagogues. Yung mga sulfonylureas. Sulfonylureas. So, based sa pangalan, you can identify na these are sulfonylureas, insulin secretagogues, based sa prefix. Usually, they start with gly with letter I or gly with letter Y. So, let's say for example, glyburide, yan, or glypizide, or glimepiride, yan. So, these are examples of sulfonylureas, glimepiride. That's glimepiride. Okay? So, these are potassium ion channel blockers. And then last, for calcium channel blockers, na usually ginagamit itong mga CCBs. They are abbreviated as CCBs. Basta calcium channel blockers. Ayan, CCBs. Ginagamit sila for cardiovascular conditions. Okay? So, ang mga CCBs, they are further classified, once again, based on chemistry, base sa structure ng mismong gamot, chemical structure ng gamot. Meron tayong CCBs with dihydropyridine sa kanyang structure, and yung sa pangalan, madali mo lang siyang ma-identify because of its suffix that ends with dipines. Okay, example, amlodipine, licarnidipine, nicardipine, yan. Basta as long as ending in dipines. That's a dihydropyridine nga calcium channel blockers. Meron din tayong calcium channel blockers na non-dihydropyridine. Dalawa lang yung pinaka-common na example, yung verapamil and diltiazem. Okay? So all these given examples na gamot, yung realization nyo dapat is they are protein targeting. And specifically, they target regulatory protein. What type of regulatory protein? Voltage-gated ion channel. So, dapat yan yung magiging way nyo to study this part no, sa discussion. You will expect na sa assessment, you will be dealing with questions wherein you will be identifying if that particular drug given is a protein targeting one. What type of protein does it target? Is it regulatory or structural protein? If it is regulatory protein nga gina-target, unsa nga klase nga regulatory protein? Is it voltage-gated ion channel, an enzyme, a receptor, so on and so forth. Okay, so that's how you should study it, identifying if it is protein targeting or not. Okay, so that's all for voltage-gated ion channel. Sige, let's move forward. The next type of regulatory proteins, we have the carrier molecules. Okay, by definition, ang carrier molecules, they are also proteins embedded in the cell membrane, or we call them cell membrane proteins. Cell membrane proteins na meron ding specific binding sites with specific binding sites. And they also undergo conformational changes. And they undergo conformational changes. So this is the definition of a carrier molecule. So in short, it's a protein, a regulatory type of protein. Specific example of a carrier molecule is yung hydrogen ion potassium ion pump, or this is also known as proton pump. So yan, example yan ha ng carrier molecule. And yung function, di ba, nito is that it mediates release of endogenous compounds, which includes acetylcholine, gastrin, histamine. This was actually mentioned no sa previous nga slides. In your part, I hope good nga inyuhang na access ang recorded lecture video. Okay? So, yan yung function ng proton pump. Importante siya kasi nagre-release siya ng endogenous compounds. Okay? Acetylcholine, gastrin, and histamine. This three triggers release of hydrochloric acid. They induces release of hydrochloric acid. And syempre, importante yung HCl, yung acidity sa stomach. That's the normal, di ba, nga environment sa stomach. Dapat it should be acid for it to be able to digest certain compounds being taken no, by mouth. And para pod activated yung mga enzymes in the gastric gastric nga, or in the GIT rather. Okay? However, there are conditions nga not anymore tolerable yung hyperacidity sa stomach. Di ba? Kapag hyperacidic na yung tao or may ulcer, may GERD, not anymore tolerated if nagsisilabasan yung mga acetylcholine, gastrin, histamine kasi mas lalong or it will really cause severity sa hyperacidity being experienced no sa pasyente. Therefore, we have drugs that are able to inhibit the function of proton pump. We call them PPIs. PPIs or the proton pump inhibitors. Okay, so kapag may dagdag na word inhibitors, that's already a drug. Okay? So, proton pump inhibitors, based sa mismong pangalan niya, it inhibits the proton pump. So, it inhibits the release of these endogenous compounds, kaya pwede siya to manage hyperacidity. Okay? So, by name, you can easily distinguish if PPI yan, ending in prazoles. Yan yung suffixes ng mga pangalan ng gamot classified as PPIs. Example, omeprazole, esomeprazole, pantoprazole, yan. Lansoprazole, except lang sa isang prazole, yung aripiprazole. Yes, very good. Aripiprazole. Kasi this is an antipsychotic. Okay? So just take note of the exception. The rest ng prazole, PPI na yon lahat. Okay? Sige. So that's the example, no? For best example, for a drug that targets a carrier molecule, that targets proton pump. Okay? Sige, let's proceed with the third. The third type of regulatory protein, enzymes. So in your biochem, last semester, you have learned all about enzymes, what are examples of enzymes. So madali lang no sa by name, mga ending in A's. Basta ending in A's, enzymes yon. And they are important na biological catalysts because they facilitate chemical reaction. Okay? So ang enzymes by definition, these are classified as biological catalyst importante to facilitate chemical reaction. So maraming klase ng enzymes and uh, and they are important no for a certain chemical reaction sa katawan. Example sa metabolism, production, synthesis of certain compounds sa katawan, they took part no ang mga enzymes. Okay, sige, let's have an example of enzymes. Halimbawa, phospholipase A2, cyclooxygenase, lipooxygenase, diba? These are enzymes and meron silang kumbaga importance in the production and metabolism of arachidonic acid. Sige, balikan natin ng mabilisan yung arachidonic acid na pathway. As we recall, ang arachidonic acid, it's a fatty acid that is produced uh, upon hydrolysis of a lipid, phospholipids. Phospholipid, this is an example of a hydrolyzable lipid. Kung ma-hydrolyze siya nga lipid, then one of its product is a fatty acid. So arachidonic acid is a fatty acid. And it is being produced via hydrolysis of phospholipid, okay, using the enzyme phospholipase A2. So that's the enzyme that causes hydrolysis of phospholipid producing arachidonic acid. Okay? Now, whenever arachidonic acid is produced in the body, its destined fate, yung fate niya talaga is towards metabolism. It is being degraded by the enzymes COX and lipooxygenase, and they produce eicosanoids. Under COX pathway, halimbawa, it produces prostaglandins. Under lipooxygenase, they produces leukotrienes. Okay, and meron yan yung mga functions or meron yan silang roles sa katawan. Kapag na-produce yung leukotrienes, may certain effect siya. Prostaglandins, ang daming subtype ng prostaglandins sa katawan na importante din for cells functioning. Okay? So yung focus lang natin dito is what are examples of those drugs nga could target enzymes, these enzymes. So pinaka-common are those group of drugs that inhibits cyclooxygenase. Diba? If you recall, NSAIDs, yung mga non-steroidal anti-inflammatory drugs, yung MOA nila, mechanism of action, is inhibiting the enzyme cyclooxygenase. Thus, inhibited yung synthesis ng mga prostaglandins. Okay? For lipooxygenase, we also have drugs no, that inhibits lipooxygenase. Those are the drugs Zileuton. Okay, yung Zileuton, ganun din. Able siya to inhibit an enzyme, and that enzyme is lipooxygenase. And then for phospholipase A2, it is being inhibited by steroids. Okay? So itong tatlong example, steroids, NSAIDs, Zileuton, kapag tinanong kayo, is it protein targeting? So the answer would be yes, protein targeting siya. What particular protein na iyahang gina-target? Regulatory protein specifically enzymes. Okay, so these are examples of drugs, no, that targets particular enzymes. So protein targeting sila. And finally, we have the last type of regulatory proteins, the receptors. Okay, so I believe everyone is already familiar, no, with the term receptor. Syempre, you had your biochem last semester, and if you can still recall, ang receptor is classified as a protein. Okay, so let's define here. What is a receptor? So as mentioned, it's a protein. It's a functional protein embedded in cells. Okay, embedded in cells with stereochemical configuration, chemical configuration. Okay, where a ligand interacts. Okay, where a ligand interacts. Usually, ang interaction ng ligand to a receptor, it's a manner of lock and key. Okay, lock and key nga manner, it should be induced fit. Fitted dapat yung mismong ligand to the active site of the receptor. So, lock key theory. So, sulat natin, lock and key theory. Okay? Sige, we actually have a separate segment wherein we'll be discussing in detail, or we will discuss thoroughly, no, what are receptors, the concept on lock and key theory, what are examples of receptors, and ano yung mga specific drugs that targets receptors. So, we'll just have a separate na segment na i-discuss natin ito in detail. I think sa mga next few slides, madadiscuss natin sila. Okay, so ako lang ni siyang skip usa kasi medyo mahaba, no, yung topic on receptors, and pila naman ang oras, 30 minutes. So hindi siya kaya. So lain siya kung iputol nato siya og discuss. Okay? Sige. So we'll just skip this. So all in all, we were able to discuss the four, or introduce the four types of regulatory proteins. Then later na lang ha, or next meeting na lang yung sa receptor. Okay? I'll discuss that after we finished discussing on the non-protein targeting na mga gamot. Okay? So that's it. That's for the regulatory proteins. Again, let me kumbaga read just to reinforce the classifications of regulatory proteins: voltage-gated ion channel, carrier molecule, enzymes, and receptors. Okay, so that's all for the mechanism of drugs action that are target protein mediated. Okay, yung mga protein targeting ones. Okay, sige, let's proceed with those drug that interacts with a body without binding to a protein. Sila naman yung mga non-protein targeting. Okay, so paano yung mechanism nila in order to produce effect even without protein involved. So there are three possible mechanisms for a non-protein targeting drug to produce an effect. It could be via colligative mechanism, direct chemical reaction, or counterfeit mechanism. Sige, let's have first via colligative mechanism. I repeat ha, itong segment na to, we will be mentioning examples of drugs nga non-protein targeting na. So they don't need to bind to the active site of the protein. Okay? So let's start with the first, mechanism via colligative mechanism. So this is the way the it's the way, or it's the mechanism wherein the drug produces an action uh, related to the colligative property of a substance. Okay? So yung mechanism niya is or has something to do with the colligative property ng isang substance. You had your physical pharmacy, di ba, last semester. I believe yung colligative property na mention. A good example of colligative property is yung osmotic pressure. And when I say osmotic pressure, very much relative siya sa principle na osmosis. Okay? So that is one of the mechanism, no, na pwedeng ang gamot via this colligative property ng substance, pwede siyang makapag-produce ng effect. Okay? Now, with regards to osmosis, you're familiar with this term, right? It has something to do with the movement of water. Okay, movement of water. But from what area to what direction? Okay? So, kapag osmosis, yung movement of water here should be from area with low solute concentration. Sulat natin, low solute concentration to an area with high solute concentration. Okay, so that should be the direction of the movement. Okay, movement of water. If it is osmosis, if it uses the principle osmosis. So padulong dapat sa sa area na mayroong higher solute concentration. So I know you're good with the term solute, solvent, diba, sa solution. Sa isang solution na ay solute, na ay solvent. Now, given this information nga yung direction is mula sa low solute concentration, kung moingon ta og low solute concentration, kana nga area also has higher solvent concentration. That's actually the same nga concept. Kung kana nga area gamay ang solute, meaning to say ang daghan ana solvent. Did you get it? Can you show a thumbs up? Di man gid na ko makita. Wala ko kabalo kung okay ba, na-gets ba? Okay. Sige, that's good. Now, on the other hand, ang iyang direction, di ba, is going to the area nga higher ang solute concentration. So, kung kana nga area, daghan ang solute, kumusta ang solvent ana nga area? So, yung solvent dyan is low, at low concentration, yung solvent. Okay? So, that is why when you search about definitions sa osmosis, it could be in either way. Pwedeng ang movement of water is mula sa higher solvent concentration to an area with low solvent concentration. Pwede pod ang definition kanang nasa taas. From an area with low solute concentration to an area with high solute concentration. Okay? Dili siya vice versa, ha? Okay, I hope you were able to point out, no, the difference. Dili siya kay last meeting sa ako ang other section. Someone, no, kumbaga initiated or iyahang pagka-gets is vice versa. Pwede po di ay daw going to the low solute concentration. No, it's a different story na. Okay, so di siya vice versa. Okay, so please take note of that. So a good example of a drug na makes use of this concept, yung colligative mechanism, yung way niya to produce an effect, is yung gamot na mannitol. Okay? Mannitol is classified as osmotic diuretic. So, based pa lang sa iyahang therapeutic classification, no, ga make use gud siya sa principle nga osmosis. Okay? Yung way niya para mailabas, 'di ba diuretic means pampaihi. Okay? So, yung manner niya or way niya para mailabas pangmaramihan yung excess water molecules sa katawan is via osmosis. Okay? So, osmotic diuretic siya. So, kumbaga, let me give you an overview lang ha sa MOA ng mannitol. Ang mannitol kasi ginagamit siya sa mga cardiovascular condition wherein nagkakaroon ng excess water molecules or fluid content sa katawan. Yan. So, pwede ang mannitol at some conditions, no, or diseases related to cardiovascular na system. Pwede siya gamitin kasi nga napapalabas niya yung mga excess water molecules sa katawan. So, this is how mannitol works. Let's say this is the blood compartment. Let me write the MOA first of mannitol. Mannitol, yung ginagawa niya, it draws out water molecules from the blood compartment, okay, compartment to urine. It draws out. So, nagdo-draw out siya ng, ayan. Nawala yung screen. Okay. Are you sure? Okay. Sa ako laging isa ka gadget. What about the rest? Wala. Sa uban, makita ang akong screen. Okay na? Okay. Sige. Thank you for that. Yes, thank you for notifying me. Okay. Ayan. Sige, I repeat, yung mechanism of action ng mannitol, it draws out water molecules from the blood compartment to urine. Going to urine. Okay, yes. Yeah, thank you for that. Thank you also. So let's say, ito yung illustration, paano nagwo-work yung mannitol. Let's say, yung nasa gitna na compartment is the kidney tubule. Usually, sa kidney tubule, yung water permeable na area or region sa kidney tubule are the proximal convoluted tubule at saka yung thin descending limb. So for now, just know na yan yung mga water permeable portions ng kidney tubule. Okay? Ato na lang ibalhin. Dito na lang yung ibalhin na to. Ang compartment. Diri ang blood. Then dito yung sa urine compartment. Okay. So yung ginagawa ng mannitol, actually mannitol, it is administered parenterally. Okay, so once administered parenterally, its effect initially is increasing the salt concentration gradient sa urine compartment or sa urinary tract. Okay, so gradient. So pinapataas niya yung salt concentration. Salt is a solute, right? It is an example of a solute. So tingnan ha yung direction. Ang sa urine compartment daw, doon yung merong mataas or higher concentration of salt, which is a solute. Saan ginagamit yung mannitol? During conditions, cardiovascular conditions na merong excess fluid content sa katawan. Example, sa atong blood. Let's say, one of the reason bakit may high blood, halimbawa lang ha, merong high blood yung tao, it's because of higher fluid content in the blood. Okay, higher fluid content. That could be one of the reason bakit mataas yung blood pressure. Okay, mataas yung fluid content, so water molecules, mataas yung sodium ion, so on and so forth. Okay? Now, focusing on the fluid content. Okay? So, yung gagawin ng mannitol para ma-excrete, mag-get rid yung excess fluid sa katawan, it will just draw out those water molecules mula sa blood going to the urine compartment. Kasi if you try to understand and analyze the areas from different compartments, dito daw sa blood, mataas yung fluid. Tingnan ha, mataas yung fluid content. Remember, kung ang area na yan, mataas yung fluid content, kumusta yung solute dyan? Mababa, di ba? Yung solute. So yan yung magiging direction ng mannitol mula sa blood compartment going to the area na kung saan higher yung salt concentration. Okay, so it follows osmosis na principle. Okay, so balikan nyo lang yung osmosis na principle. Movement of water, meaning the fluid, the solvent, from an area with higher solvent concentration to an area with a higher solute concentration. Okay, so ito man yung magiging direction. Dito papunta yung movement ng water. It's either higher ang solute or papunta siya sa low solvent concentration. It's the same concept pa rin. Okay? Sige, can you show a thumbs up if you understand the concept? Okay, I know you will understand, mga bright man ni akong mga estudyante. Sige. Let's have the second mechanism. Okay, yung second mechanism has something to do with direct chemical interaction. Okay, with regards to direct chemical interaction, meron tayong mga gamot na yung manner naman nila to produce an effect is via simply causing chemical reaction sa katawan. Sa chemistry, you have learned a lot of types ng chemical reaction. Example ng chemical reaction, neutralization. Diba sa laboratory, kung mayroon kag mag-neutralize ta, it is all about, sige nga, all about what? What are you interacting if you try to neutralize sa laboratory? Kung mag-neutralize ka, what is being interacted? Sige, just to assess. Go. Kung mag-neutralize. It's a man. Okay, very good. If it is all about neutralization, you are interacting an acid and a base, forming a salt. Okay? So we have examples of drugs na yung mechanism of action nila is via neutralization. Very common examples, antacids. No? Yung mga antacids. Para saan yung antacids? For hyperacidity. Okay? So during neutralization, this substance, ang mga antacids, they will just act as the base. Sila yung base. They will try to neutralize the stomach acidity. So that is neutralization. Okay, another example, sodium bicarbonate. Ang sodium bicarbonate, this is commonly used for metabolic acidosis. Okay, the problem during or having this condition, kapag ang tao may metabolic acidosis, yung problema is low yung level ng basic ion, the bicarbonate ion. Syempre, if lowered yung bicarbonate ion, which is the base, physiologically, the acidotic environment will dominate. Okay, so to manage this condition, we can make use of sodium bicarbonate na substance. Since it has bicarbonate in it, then it will just replenish what is lacking. Okay, what is deficient. No, mababa man yung bicarbonate. So iya lang i-replenish, and that is neutralizing, okay, the condition. Okay, so this will be the base. in the reaction. Okay. Another example is protamine. Protamine is used for heparin toxicity. Okay, and yung mechanism niya to manage heparin toxicity is via neutralization as well. Yung protamine kasi, chemically speaking, yung chemical structure niya, it has an amine. And amine acts as a base. They act as a base. Basic yung property, kumbaga, ng amine na entity. So, in this reaction, yung heparin dito will be the one na mag-act as acid. So, siya yung acidic dito na compound. So, it's neutralization pa rin na concept, okay? What else? Aside from neutralization, we also have another, kumbaga, type of chemical reaction nga pwede din mechanism ng gamot to produce an effect. So, example is yung chelation or complexation. Okay, chelation or complexation. Example ng gamot that makes use of this mechanism is yung deferoxamine. Okay, deferoxamine, it is used as antidote for iron poisoning. Let me spell it out. Ayan, deferoxamine. Okay. Again, ginagamit siya for iron poisoning. Okay? So that's it. So yung way, yung manner or mechanism ng deferoxamine to lower iron level in the blood is simply by forming complex structure with iron. So magpo-form siya ng complex structure with iron metal resulting to a compound nga non-absorbable already or inactive form of iron. So let me show you the reaction. Example, this is the ferroxamine with iron that tends to form ferrioxamine. It's an inactive form of iron, non-absorbable na or excretable siya nga form of iron. Kaya a very good nga antidote yung deferoxamine for iron poisoning. And yung mechanism niya being an antidote to relieve iron poisoning is via chelation. Okay, so it's a chemical reaction, direct chemical reaction. Okay. Sige, let's proceed to the last mechanism for those non-protein targeting na mga gamot. We have the counterfeit mechanism. Yung counterfeit mechanism, this is also known as incorporation. Incorporation. Incorporating. Okay? So, okay, before we give example, let's try to understand first, no, the mechanism itself. When you say counterfeit, it is synonymous to the term false or fake. Okay? So, kumbaga, what happens here is we simply incorporate a false substance, a fake substance. It will be incorporated in the body, causing alteration in the functioning, normal functioning of the body. So that's the concept of counterfeit mechanism. Example of drugs that makes use of this mechanism are those anti-metabolites. Okay, so ang mga anti-metabolites, these are just false metabolites. Hindi sila yung totoo, yung natural nga metabolites which are needed for cell synthesis. Okay? By the way, ang mga anti-metabolites, they are used as cytotoxic agents. Anti-cancer also. Okay? Anti-cancer agents. Cytotoxic sila. Cytotoxic. They kill. cells. Okay? Kaya nga pwede sila as anti-cancer agents. Okay? Sige. Let's try to understand why. Why anti-metabolites can be used as anti-cancer. Okay. Now, let's go back to the overview sa cancer cells. Recalling na one of the important or preparatory stage nga para makapag-synthesize ng any cells, may it be normal or cancer cells, it's the DNA synthesis, 'di ba? Kailangan ma-synthesize yung DNA. Okay? So, that's why kapag may DNA, there will be cell that will be synthesized. Importante kasi siya na component, 'di ba, for a cell. Okay? So, cancer cells, they rapidly cell divide, they rapidly proliferate, divide, reproduce. Then for them to reproduce, dapat moagi gyud na sila og DNA synthesis. 'Di ba? You have learned how a DNA is synthesized. What are the kumbaga structures of DNA from primary to secondary, tertiary na structure of DNA. So recalling na sa isang DNA structure, any nucleic acids, there are nitrogenous bases. We call them pyrimidine and yung purine na mga natural nitrogenous bases. So ito yung mga sinasabi natin na natural metabolites, yung talagang totoong metabolites that are needed for the synthesis of DNA. And that contributes to cancer cell proliferation, okay, or reproduction. Okay, so if these natural metabolites in our body will be the one to contribute sa DNA synthesis sa cancer cell, that would be a problem. Kaya magpadayon man yun na ang cancer cell proliferation. Musamot, kadaghan, reproduce siya. That's why we have anti-metabolites. Okay, we have anti-metabolites. Wala, nakita na nako si magkatawa ko sa iyang now. Anti-met, hello. So, ito yung name?
Hi, ma'am! Hi, ma'am Sally.
Nakalimot ko sa mong apelido. Basta kaila ko sa imo. Kaya ang pangalan na Saran?
Ligan, ma'am, Miguel.
Oh, si Ligan. Yes. Of course, I remember your face. Nalimot. Yeah, it's okay. So, okay. So that's why we have, I'm sorry for that. We have anti-metabolites that are used to be incorporated in the DNA synthesis para mapigilan yung pagrami ng cancer cells. Kasi ang yung mga anti-metabolites, diba sabi, sila yung false one. False nga metabolites, hindi sila yung totoo, ika-copy lang nila yung hitsura ng mga natural ones. Ito yung mga purine analogs. Okay, purine analogs and yung pyrimidine analogs. Yung kapag analogs na, they look like, structurally they look like the natural purines, they look like the natural pyrimidines na yung talagang kailangan for DNA synthesis. Okay? So sila, i-incorporate sila, pero yung gagawin nila, they will inhibit DNA synthesis. So if these are the anti-metabolites that are being incorporated along the process, iba yung gagawin nila, inhibited yung DNA synthesis. Kaya mapipigilan yung cancer cell reproduction. Okay? Sige. Example of purine analogs, by the way, is yung 6-mercaptopurine. Mercaptopurine. Pyrimidine analogs, we have 5-fluorouracil. Okay? So, yan. So if you try to understand, hindi talaga sila yung totoo, no, na purine at saka pyrimidine bases. Naalala yung uh, mga mnemonics that I have provided to you kapag purine bases, yun yung purga. Purga, yung guanine at saka adenine. Yun yung natural nga N bases, not nitrogenous bases. Sa pyrimidine, we have yung picot. Naalala yung picot, cytosine, uracil, thymine. Yun yung dapat for DNA synthesis. However, if itong mga analogs yung na-incorporate sa DNA synthesis, iba yung action nila kasi hindi sila yung natural ones. So they will just inhibit DNA synthesis once they are being incorporated to DNA or RNA synthesis. Okay, so that's the action of anti-metabolites being an anti-cancer agent. So they make use of this mechanism, counterfeit mechanism. Okay, so these are the three mechanisms of how non-protein targeting drugs uses para makapag-produce sila ng effect. Colligative mechanism, chemical reaction, or counterfeit mechanism. Okay? So overall, we're done discussing the first part sa pharmacodynamic principles. Excuse me. For the receptors, ito, yung utang ko, idadiscuss ko na lang siya next meeting. Okay? Para hindi putol yung sa receptors na concept. Okay?